the components of a vector. The horizontal component v sub x is equal to v times cosine theta. The vertical component of a vector v sub y is equal to v times sine theta. Let's look at an example. This vector v forms a 30-degree angle with the x-axis. This angle, theta, is equal to 30 degrees. Now, we have the value of vector v, which is 10 meters per second. It's the velocity. The horizontal component v sub x is equal to v times cosine theta, which in this case is 10 times cosine of 30 degrees. That is 10 times square root of 3 over 2, which is 5 times square root of 3, which is 8.5 meters per second. The horizontal component of the vector, which is equal to v times sine theta, in this case is 10 times sine of 30 degrees, which is 10 times 1/2, which is 5 meters per second. So let's look at an example of a projectile motion, that is, the motion of a bullet. This is the point where the bullet is shot. This is the point where the bullet reaches its maximum height. And then it starts falling down, and here is where and when the bullet touches the ground. This distance from the starting point to where it touches the ground is called the range. Let's suppose that the initial velocity is a vector whose intensity is 100 meters per second, and the angle with respect to the ground is 30 degrees. The two components, the vertical component is going to be 50 meters per second, and the horizontal component is going to be 85 meters per second. The first thing we need to do is calculate the length of time, how long the bullet takes to stop going up. This is where it stops going up because of gravity. Gravity causes an acceleration, a negative acceleration of negative 9.8 meters per second squared. So we know that the initial vertical component is 50 meters per second. When the bullet touches the maximum height, the velocity is going to be 0 meters per second. So very easily we can calculate the length of time, which is delta V over A, that is 0 minus 50 meters per second, over negative 9.8 meters per second squared, which is approximately 5 seconds. So the bullet reaches the maximum height after 5 seconds. this is where the second part of the problem starts. When the bullet has reached the maximum height, it means that it's no more going up because his vertical component, the vertical component of the velocity is now 0 meters per second, but it's not yet going down. It's a moment of no movement. We only know, but it is all we need to know, the maximum height, which is 125 meters. Now we need to calculate how long it will take to go down and touch the ground. The formula is the same, but in this case, the final position is going to be 0 meters. The initial position is 125 meters. The initial vertical component of the velocity was 0 because, as we said, it's no more going up, it's not yet going down. This is what we are going to calculate, but in this case it's going to be cancelled because there's a 0 here, plus 1/2 times g, which is negative 9.8. And this is, once again, the time needed to go down squared. So you can easily see that this is going to be a constant formula. 4 times 9 point delta t to go down squared is equal to maximum height. So the time to go down to touch the ground is always the square root of the maximum height over 4.9. So the bullet takes 5 seconds to go up and 5 seconds to go down. So all in all, the bullet keeps moving for 10 seconds. Now we need to calculate the range. The range is something horizontal. There are no forces acting on the bullet horizontally, but only vertically. So there's no acceleration if we consider the horizontal movement. So what we need to do is multiply the horizontal component of the initial velocity times the total amount of time that the bullet is moving, which means 85 meters per second times 10 seconds is equal to 850 meters, which is the range of the bullet.